we're gonna get started. Yeah, that's a good way to start. Um, Welcome to our August Chicago Ruby Meetup, the Cozy Edition. As a reminder, we aim to meet every first Wednesday of the month. We want to thank workforce.com for letting us use their space and being such a gracious host. Um, with that, I'll I'll probably hand it off to Meg if she has anything she wants to say. No. Yeah, probably important.
So for women, 5501, guys. And
Okay.
then for the men's restroom, it's 5502 pounds.
Cool.
Yeah. So if anyone, and then if you have any questions or need anything while you're here, let me know.
Great. Thank you. For those who joined us late, there are snacks over there, there's drinks over there. Feel free to grab whatever. Yeah. Nope. Next thing. All right. I'm gonna do some quick housekeeping and announcements. First, join us for our future events. We'll post our events on meetup.com as well as our community Slack channels. So hashtag Meetup USA Midwest, community social random on the Ruby Central community Slack, as well as the Ruby channel within Chicago Tech Slack. I'm not the best at doing this, but I'm trying to get better. So bear with me on that. Reach out to me if you need an invite to any of these Slack channels. All right. Yeah, interested in hosting? Chicago Ruby is on the lookout for organizations willing to host our monthly meetings. If interested, please reach out to Anton, Daniel, or myself, and we can give you more info. I'm gonna move this really quick. Okay. Yeah, we want to hear from you. Interested in speaking? We'd love to hear from you. Feel free to reach out to me, Anton, or Dan for more information. If you're interested in hearing more about a topic or but unsure, or if you're interested in speaking but unsure what to talk about, or if you're interested in hearing a specific topic, we've compiled a list of potential topic ideas that members of the community are interested in learning more about. Feel free to add your ideas here. There's a QR code to that Google spreadsheet. For moderation purposes, this spreadsheet is open for comments only, and admins like myself will add ideas from the comments onto the list. If you're interested in supporting Chicago Ruby, either by hosting or hosting a different type of event like a hack night, code and coffee, collaboration with other groups, or through a sponsorship, we are so down. Let us support you, support us. Reach out to me for more info. Yeah. Some announcements. So these companies have reached out to us to share the word that they are hiring. First, our gracious host, workforce.com, has an open senior developer position. Reach out to Meg Beavies for more information. Prevail.ai is hiring a mid-level as well as a senior full stack developer. Reach out to Dan. He's here. He's over there. Yeah, he's here for more info. Reverb is hiring a senior software engineer. Reach out to me and I can get you in contact with their HR manager. Red Circle is also hiring. They are hiring a Ruby integration engineer. Reach out to me and I can connect you with the Red Circle CEO, Mike. Yeah, and I'm gonna leave the mic open for like a minute or two if anyone else has announcements or job openings. That's been a minute. We're moving on. All right. Yeah, more exciting news and general announcements. XO Ruby, a regional conference, or rather, a conference pop-up in multiple cities, is coming to Chicago Saturday, September 6th, 2025. It'll be at the Fulton Street Collective on Saturday, yeah, September 6th. There will be certain members of our local community who will be there to speak, so it'll be a great opportunity to support them. To learn more about XORuby, go to xoruby.com/event/Chicago. Tickets are limited. Their capacity is capped at 80 attendees, with ticket prices being $100. If you have any questions, feel free to contact xoruby at beflagrant.com. There's also a XORuby channel within the Ruby Central community Slack. Ooh. All right. Lastly, join us next month. If you cannot attend XORuby that Saturday, good news for you, we'll be hosting a Chicago Ruby event the second Wednesday of September, September 10th, from 6 p.m. to 8:30 at Beyond Finance. Pravanth Shiva and Aji Slater will be speaking at this next event, and I'm super excited to hear from them. They're so awesome. And with that, I will hand off the baton to our first speaker, Stephen.
Okay, thank you. Let me turn my video on and share my slides. Let's see here. Button, share. Okay. Everyone can hear me. Everyone can see my slides. Perfect. So today I want to talk about testing background jobs, which is a topic I have been interested in for a long time and fascinated by for the last year or so. And I want to start off with a bit of a spicy take that hopefully by the end of this talk won't seem spicy at all. But testing a background job requires testing retries. And for me, this was the key insight that really unlocked my understanding of how to test background jobs well. Because what I came to realize after years of trying different approaches, writing tests for different types of jobs and different scenarios, was that the most productive type of test for a background job was a test that really leaned into the unique aspects of background jobs. Sure, there is value in writing a test for the straight green path of a job and treating it like any other synchronous code that you have in your application. But the fact of the matter is that what makes background jobs unique is that they aren't running in the standard synchronous execution environment that our model methods are or our controller methods are. Background jobs run in an asynchronous environment that is eventually consistent, that is trying to be self-healing. And this comes with a powerful and unique property where when exceptions are raised, our background job system will attempt to heal from those errors by retrying that job. And this means that our jobs can behave quite differently. And the best tests, the highest leverage tests for jobs, are going to lean into that unique characteristic. So what I want to do for this talk is basically to walk you through the aspects of a gem that I have made, which packages up all of the different features that I have found myself needing in writing tests for background jobs over the last couple of years. And I need to start, obviously, with how do we test retrying jobs? If we imagine a really simple active job like this that is just going to raise a standard error on the first execution, but not on the second. And it's important here to note that when we're talking about testing retries in jobs, we're specifically talking about testing for transient errors, right? We can distinguish permanent errors from transient errors, and testing permanent errors is fairly useless because by definition they're permanent, right? The job can never and will never recover from them. So it might retry 1, 2, 25 times. It'll end up in the same state. It's going to hit a brick wall at a particular point in the execution flow of that program, and it'll always hit that error and it eventually will exhaust the retries. What we are interested in is retrying transient errors, errors that occur sometimes but not always. That is to say, errors that our job could heal from through retries. So in this case, we have a transient error. It occurs once, but it doesn't occur on the second run. And if you are someone who has worked with the active job test helper, you, like me, would likely write your test something like this. You would perform the enqueued jobs, probably pass in a block, enqueue the particular job under test, and write some assertions once the job has been performed. And for the longest time, I thought this was perfectly good and fine. And I was surprised when I came to realize, after testing some more unique and complicated jobs, that this is not fine. Um, the perform and queue jobs method actually behaves notably differently from production. And if you have jobs where the behavior is important, that difference can actually lead to false positives or even false negatives in your test. But to be more concrete, let's look at a simplified version of our logs that we would see in running that particular test. So this is problematic. Specifically, what's problematic is when we look here, we see that the first log says that we're performing job one, right? The first execution. And then the very next log that we see is that we're performing job two, the second execution. This is bizarre. If you were to see this in your logs, I would hope that you would be caught off guard. We would not expect this. If we continue, we see this block of logs for the second execution. So we're performing the job, we have performed the job, and then at the very end, what we see is that we have enqueued the job. This should also strike us as quite odd. This is not what we would expect to see. What we would see were we to run this exact job in production is this. Logs that had this kind of structure. So we would see that we are performing job one, and then the next log line would be that we have enqueued the second execution of that job. And we would see that after enqueuing the second execution, that we are in fact retrying job one. See that log line. And at the very end, we would see, okay, yep, I have finished performing job one, and now I'm performing job two, and now that is done. Like this is the flow that we expect to see. So this difference in behavior is subtle, but can have real meaningful effects for writing correct and consistently useful tests. So what are we supposed to do? Well, if you explore the active job test helper, you will eventually find your way to writing your tests like this. This is how I have been writing tests for a long time now. So instead of calling perform and queued jobs, I call flush and queued jobs. And the difference here is that what perform and queued jobs does, right, is it switches. We already know this, right? We're going to switch our job adapter in our test environment to use the test adapter that is provided by active job. And performing queued jobs overwrites the enqueue method that is used by active job. And instead of enqueuing it, putting it into a queue, which then a worker picks the jobs up from, it just overwrites that method to call perform, the instance method on that job instance directly in line. So that's why we see as soon as we start performing the first execution, the next log line is, hey, we're performing the second one. And it's only at the very end of that that we see that, oh, we haven't queued because it's at the end of the execution of that block that the log for the enqueue method is actually triggered and everything sort of flows from that. What we want is to run jobs like they run in production, which is in waves, right? So I run a job, it might enqueue some stuff. Once that job is finished, then the next wave will come, right? Our worker will go and pick up a new job and run that through. Maybe it'll enqueue some things. So if we just run a loop when we're checking, do we have any enqueued jobs? If we do, perform them. Flush enqueued jobs means basically pull them off of the queue and perform them. This is going to behave the way that we want, right? This is going to mimic production. So this line here is how we're going to test our jobs for retries more correctly. And I thought that this would be all that I needed. And it's all that I used for a while. But eventually, I came to realize that this too was insufficient because I started testing jobs that enqueued other jobs. So let's imagine a simple job like this. Here we have another transient error, but before we hit that transient error, we schedule a job in the future. If we want to test a job that looks like this, our flush enqueued jobs approach isn't going to mimic production the way that we want. If we look at our simplified logs again, the problem jumps out here at the bottom. We see we're still performing in waves. That part is correct. But what we see here is that we're performing the scheduled job before we perform the retry of the job itself. And this is not the way that production would behave. We have scheduled our scheduled job to perform in the future. And so in production, what we would see is that the retry, which isn't scheduled for the future, is just going to happen as soon as possible. It doesn't have a schedule that set. It's just immediately enqueued, would be picked up before the scheduled job is picked up. So the retry would be performed, and then the scheduled job would be performed. So I found myself wondering, how can I write my tests to mimic this behavior? I don't want to actually wait the amount of time that is scheduled. I want to collapse all of the real world time to have things run as quickly as possible. But I want the order of operations in my test environment to match my production environment. And I came to see basically this is what I would need. I want to take my enqueued jobs array that is provided by the active job helpers and sort it by whether or not there is a schedule at, and if there is, checking which one comes first or last, and treating any jobs that aren't scheduled at as jobs to come to the beginning of the queue. And then just taking that ordered set and flushing that set of jobs. Unfortunately, for reasons I can't speak to, I don't know, you can't simply flush an array of jobs. The active job test helpers only provide you with the specialized helper to flush the enqueued jobs array or flush the perform jobs once again, and you can't mutate those arrays before flushing them. So this problem is what led to the first of the chaotic job helpers. So you can include the chaotic job helpers module into any of your tests or into your base test class, and it's going to give you this method, perform all jobs. And what perform all jobs is going to do is it's going to sort your enqueued jobs in the way described, and it's going to perform them in this queue like wave system where we're flushing the sorted enqueued jobs each wave until we have no more jobs that we need to perform. And if we need even more control to perform a subset of the enqueued jobs, we also have these methods. We can perform jobs with time ranges. So any jobs that were scheduled to happen within the next 4 seconds, or jobs that were scheduled to happen after 7 days from now, or whatever duration you might want, you have full control. So you can perform all of your jobs following the exact behavior characteristics that you would get from production, fast forwarding any real world time, with full control over which subsets you want based on when they were scheduled. And this is the foundation upon which you can start writing correct tests for background jobs when you want to test for what happens on retry. But when you have that foundation, you will start to realize that this alone isn't quite everything that we need. Because in addition to having our retry mechanics match production in our test environment, we also need to be able to easily create failure scenarios. So we can imagine a simple job like this, right? The perform method does three things. It does something else, and does another thing. And we want to write a test for the situation where a transient error occurs right before we start doing more things. How do we write that test? Well, you might start to reach for a mutation of your job to make it more test friendly, right? So in this example here, I've set up a class level instance variable, which I use to control whether or not my transient error is going to actually raise. And that allows me to write a test that would, in fact, um, raise an error on the first run, but not the second run. And this is a code smell, right? If we start to meaningfully change our code in order to make it testable, and the code that we are writing is brittle and has no other value for our job than making it testable, like that's a code smell. We don't want to do those kinds of things, but we do need to find ways to uh, define and run ad hoc specific failure scenarios. So the next thing that chaotic job provides, and really the core concept at the heart of the gem, is the concept of a glitch. So a glitch is a way of forcing a transient error to happen in a particular place. And because this is so central to everything that the gem does, I'm going to take a bit more time on this concept to really make sure that we all understand how it's working. So I'm going to come back to the sort of full set of this code, but for now, I want to focus in on these lines, right? So we get a glitch instance by calling this helper method glitch before call, where we take a block where we're going to raise this retryable error, and then we inject that glitch instance by passing another block, and inside that block we call perform all jobs. So what's happening here? What are these helper methods doing? So let's start with this glitch before call helper method. This helper method is syntactic sugar for calling this class level method on the chaotic job glitch model. Not a model, just a class. So let's look at that class. The before call class level method is just a bit of sugar for initializing an instance of this with a particular value at the event positional argument. So we see here that a glitch instance takes some key, some event, and some args, a return value, some kwargs, and a block, and just stores that as instant state. We will come back to understanding these things a little bit. As for that second line, injecting that glitch around a block, if we look into the source, we will find the inject method looks just like this. Let's walk through it step by step. So at the heart of a glitch is our use of the trace point object from the Ruby standards library. And this is a really powerful tool. If you haven't heard of it, I would be happy to talk about it more in the Q&A session, but I don't have the time now. Suffice it to say, it is the way that we can see what Ruby is doing as it is executing a program. So we're going to set up a trace point. We're going to set up an observer of the execution of a program. And we're going to pay attention to the particular event that you have told us to pay attention to. So in our case, it's the call event. So we define a callback, right? So what are we going to do whenever one of these events happens? So the first thing we do, we're going to take the event, our TP variable here, and we're going to derive a key. And we're going to check if the events key matches the key that we have set up on this instance. So what do these derived keys look like? We scan our code, we'll find the derived key method here. So we see we're just generating these strings, and we have these different string patterns for the different types of events. So for a line event, you're going to see the path to the file, and then a colon, and then the line number. So this is like the signature for defining a particular line execution. For the call and return events, we see the receiver and the method name. And if it's a class level method, there's a dot. And if it's an instance level method, there is a pound. So these are just string signatures to describe a particular event that can happen in the flow of our program. And we derive these keys for every event that happens, and we check them against the key that you provided. So just to run back, what we have here, we wanted to glitch before the job do more things instance method is called, right? So our call event is what we are checking for, and our key is this string job do more things. So when we make this check here, we, for every call event that happens, we derive its key, and we wait until we find the call event that is for our instance method that we care about for this particular glitch. So until we have that match, we just keep next, next, next. But once we do, we move on. And we move on to the next batch, right? So we're going to derive matchers for this particular event, and we're going to check, do our matchers match the glitch instance that we have? Deriving matchers, you will see there are no matchers for line events. For call events, we take the parameters of the event, we use the binding to get their values, and we return this tuple of the type of the parameter, the name of the parameter, and the value that it has. For the return event, the type is a return value. It has no name, and we just return that value. This allows us to define glitches, not just for any time that a method is called, but when a method is called with particular arguments. And it can be specific or generic, right? We can say whenever this method is called with a string in its positional argument, when this particular string is called, we're just going to use triple equals matching there. So in the call case, we are going to get those values, and this allows us to check whether or not they match. And as I said, I'm not going to show this method, but this is just a triple equals. So this just gives us fine-grained control over whether or not a particular event should trigger our glitch. So if we have a program that executes a particular method 3 times and we only want to glitch on the third one, how do we distinguish that? We can distinguish it by its arguments. But if we have a glitch that matches an event, we are going to execute the block. And executing the block is pretty straightforward. We have some instant state to track whether or not we have already executed the block. So this is what makes it transient. We're going to execute it the first time, update our state, and the second time we will short circuit. We're not going to do anything. We'll just say, I've already executed. So with our trace point defined, we just enable it on the block of code. And that moves forward. So in this case, this block of code was the perform all jobs block, right? That's what we had before. So whenever that block of code is running, this trace point is active. So that's what it looks like to inject a glitch into some particular program. So jumping back to our test now, we can see at the job itself, we define a retry on. We don't have to do that inside of the job. We can do that just inside of our test. And we then enqueue the job. We set up our glitch. So our glitch is targeting this particular instance method being called. And whenever that event happens, we execute the block, and what we want the block to do is to raise this particular retryable error that we've set up for our tests. Then we inject that glitch into the perform all jobs execution flow. So as the jobs are being performed, whenever we get to calling the do more things method, our retryable error will be raised on the first run. The job will get retried, re-enqueued, run again. The second time, the glitch will see, oh, I've already raised the error. I've already executed the block. It'll do nothing. The program will continue on, and then we can start our assertions. So this is great. And this allows us to set up failure scenarios really easily. But it's not good enough because there's a lot of boilerplate here. And 90% of the time, 99% of the time, you don't need that boilerplate. You don't need that level of control. So the next helper method that you get from chaotic job is this run scenario helper method. And all you need to do is pass an instance of your job, right? And you can set up that instance however you want. It's worth reminding ourselves that even though the way that we interact with our jobs is through class level methods, that active job actually uses instances, and you can initialize a job instance with all of the arguments that needed to be passed to perform. And then you can just call perform at that point. There's some meta programming that active job does to make that work. But if your perform method takes arguments, you can initialize an instance of that job with those arguments, and everything will be fine. And then you just pass in the glitch that you want. So you don't have to set up the retryable error retry on. You don't have to make sure that your glitch is going to raise that retryable error, any of those things. You just say, I want to run a particular glitched scenario. Here's my initialized job. Here's the glitch I want to run. The end. This developer experience is much nicer. And this is really the heart of what chaotic job does. But it's not all that it does, because after I built this feature, I had a realization. And that realization was that once you can really easily test a particular failure scenario, it becomes possible to simulate all possible failure scenarios. So the next helper that you get is a class level helper. Right now, Chaotic Job is a mini test framework. I am looking for someone who is an RSpec lover and an RSpec expert to help me port this to RSpec. I personally don't use RSpec, haven't used it in years and years. So I'm just not familiar with it enough. But in Minitest, I have a class level helper that's just going to create a number of test methods for you. And it's even simpler. So this time you just pass your job instance to the test simulation helper, and then you define a block. And in that block, you write assertions. And what this test simulation is going to do is it's going to figure out every possible error location in your job. And then it's going to run a failure scenario for each one of them. So to go back to our simple job example from before, here's all of the failure scenarios that are possible. We could have a failure before the do something method is called, before the do something else method is called, before the do more things method is called, and before the method actually returns. And I'll just add a note here that one of the great values of this test simulation helper, of this idea of simulation testing for background jobs, is that it will help catch these gaps in our expectations. I cannot tell you how often I have written a job. Even after doing all of this work, I've spent a lot of time thinking about writing resilient background jobs. And literally, probably 80% of the time, I write a job and I really am trying hard to make it resilient. And I set up my simulation test and it breaks. And it breaks because there's a case where a retry is, a glitch is injected in a place that I just didn't expect it to be injected. And I get into a wonky state that I'm not actually resilient against. And it helps me write better jobs. And this return case is one of the most common. I forget about it all the time, but it is totally possible to have something go wrong at this moment in the execution flow of your program. And to write resilient tests, you need to handle that case correctly, right? The case where you do everything except for mark the job as complete. And so when the error happens and you retry, you do everything a second time. And how do you handle that? So this is an incredibly powerful tool. It does require that you write good assertions, but that's true of every test, right? A test is only as good as the assertions. So you have to find the core assertions that are generally true for every single execution path of this job across all failure scenarios, all different places where it retries. So we run the do something method once, twice, three times. We run there are all kinds of permutations. And you really have to find those core assertions, like what are the idempotent results that really define a resilient run of this job. But once you have good assertions, and writing a simulation test helps you learn that art, you don't get much better than that. Um, so when it comes to testing, you get a really powerful set of helpers from chaotic job. You have production mimicking performance characteristics with the perform all jobs helpers. You have really easy failure scenarios by leveraging glitches. And then you can layer on top of particular failure scenarios just generic simulation tests. That's not all that chaotic job does. There's a few other tools I have found myself needing as I write tests myself. So it comes with a journal. So if you are writing jobs inside of your tests, I find myself doing this in working on other gems for writing jobs. I write my own test jobs, and I need the ability to do work inside of them and test against that work. And you also have a switch. This is like going back to our signal example, an easy way to control flow something happening in a job once a particular condition is triggered. These are more helpful if you're writing code like a job concern that gets added into jobs and you want to test that concern. So you define a job inside of your test. These kinds of helpers become really useful then. Um, but that right there, so this slide and the previous slide is the entire public interface of chaotic job. There's nothing else to the gem but this. And those tools I have found to be completely sufficient. Maybe you'll come up with some ideas yourself um, to make my jobs more resilient by writing really great tests. So that's what I have for you today, and I'm happy to take any questions.
Yeah, you can just,
Cool. Can you hear us, Stephen?
can you hear it?
Yes.
Hi. So what's restricting this to jobs? So like it seems like the what's it called glitches. It seems like glitches to me sound like stubs in like mini test or RSpec. But the test scenario one is interesting. It seems like could that just be could you expand that to apply to any class? Why is it restricted to jobs?
Well, it's restricted to jobs because um, you have so the idea of a failure scenario is it expects things to heal, right? So a transient error is only a transient error if you rerun the code that hit the error. So in the context of jobs, like that is a part of the infrastructure. So when we're doing our perform all jobs method, right? Like we enqueue a job, we run it, it raises an error. Active job is configured to retry on that error. So it enqueues a retry of that job. So we have another job in the queue. We pick up that job and we run that. All of that is just handled for us by active job and correctly implementing the perform all jobs helper. If you have an environment that you have set up yourself in your app where by some other mechanism you try to recover from errors, exceptions in your application, then the 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 glitches are indeed useful. You would have to set up your own, I'm going the wrong way here, boilerplate, right? To use the glitch and to figure out in your test how to uh, run things. But the reason right now that it's focused on jobs is that that is the one place in vanilla Rails where you get this behavior of self-healing. And so we can take all of this manual work and hide that behind a simpler run scenario method and just configure the job in the right way, use the correct helper method to perform those jobs, which leverages the test adapter from active job and all of like the boilerplate to work within a self-healing environment. If you've got a different self-healing environment, you can write your own boilerplate and get it to work. But I personally just have not created such a separate, different type of environment where there is a meaningful concept of transient errors. In any synchronous job, right, an error is an error, right? So it just halts the execution flow of that program, and no system does anything to try to pick that up again.
Yeah, typically what I'm thinking of is like every web application, when somebody encounters a 500 at 5xx error, the person retries the request almost entirely. And so like that's the failure, like the self-healing case I'm thinking of. Is like you have a client application that's calling web service and just like tries to submit the form again because that's what they do. Like, so that's where it would be useful. I had a second question, which was why test with perform later rather than just testing with perform now? Why not just execute the job in line rather than through a job execution adapter?
Well, the short answer is I try to write my tests to match production behavior as much as possible, right? So the problem with performing queue jobs is that that is basically what it's doing. It translates a code path that in production would in queue something, and then you'd have a worker pick it up and into just like, I'll just run this code right now. When you say to enqueue it, I'll actually just call perform now. And unless I call perform now in production, then I don't want to do that. I want my logs to be the same. I want the execution flow of my program to be the same. I want to just reduce as much as possible opportunities for squirrely errors or differences. And so for every job where I actually enqueue it, I want to reproduce that in my test environment in a way that is as fast as possible on the one hand, but as similar as possible on the other. So by calling perform later, putting it into the enqueued jobs array of the test adapter, and then having the perform all jobs helper pull it out of the array and call perform on it, such that we are mimicking a separate worker process picking up from a shared queue. I have a test that much more similarly mimics what's actually happening in production. And I found these inconsistencies by writing tests for jobs where those inconsistencies actually mattered. So they are rare, and it's true that a fair bit of the time you could just perform it. But if you do that, you don't have all of the boilerplate, right? So the active job test helpers have all of these tools and things, like the enqueued jobs array, that make testing for retries much simpler. So if I just call perform now, and there is no, I've not put it in an array, I've not done anything, when an error happens, it, I have to manually like go find my adapter, find the array of jobs where that was stored, pull it out, say, now I want to perform now this thing. So it just adds boilerplate, where if you lean on the conventions, then testing for retries, all of that stuff will just work by calling perform all jobs.
Because so what I'm thinking of is when I've written testing based on performing later, that aspect you mentioned of like a separate worker process actually picks it up is what fit me, where I wrote tests that asserted things like you have here, like it's going to retry and then it's going to have some effect on like the model that it's mutating or something. But in actual production, you have hundreds of workers that are operating in parallel, potentially on the same records. And so if you like retry something, then that record is not in the same state as it was on the first attempt. And so like I got bit by those things. Have you not gotten bit by those?
Well, yeah, that is a class of inconsistencies between a test environment and a production environment that is very difficult to simulate. What I have found for myself is that I have gotten close enough to simulating those odd scenarios through the simulation tests, right? So what where it is hard is to really quickly and easily sort of like simulate an environment where you have hundreds of parallel workers. Um, the natural test environment of just having this array that you are making use of inside of one process, inside of one thread, is super fast and super easy. But yeah, you don't hit these more odd cases. But if you can set up a simulation test where you literally force an error to happen at every single event point that occurs, not every single event point, but every single call, return, or line event point that occurs inside of your job, um, I have found that to hit a very large swath of the kinds of odd bugs that I run into in concurrency problems. And then if I find one that it doesn't hit, I end up using the lower level tools to set up a particular regression test where I set up the scenario with a little bit more boilerplate to produce the failure case, and make it work. But in my experience, simulation testing has been sufficient to a vast majority of the time uh, to sort of ferret out those kinds of interesting cases that we run into without having people, unplugging our servers at particular times, but we run into more typically in production through concurrency and parallelism with largely scaled out job systems.
Yeah, which makes sense because I think that in my head, as far as I understand you drawing it, that simulation thing is kind of like the brute force approach of at every debugger point, what if it fails? And then it's just like you have to handle every single one of those cases. One thing I was interested in is, are you able to say, I don't want to handle that case for your simulation testing?
Yes. So there are a few more options available. So if we go to like this test simulation helper, this positional argument here for the job instance is required. There are a number of keyword arguments that are also passed that you can provide. And you also see here that the block takes the scenario instance. So chaotic job has a scenario class, which is what we actually set up in that run scenario helper, which provides some state around this idea of a failure scenario. And that scenario also has some methods. So there are a couple of different ways. I've exercised this gem the most inside of the tests for acidic job, and I have one place in there. I can go and find it and pull it out and put it in the chat a bit later, where I skip a particular scenario. But it's generally like I'm pretty sure that the pattern I ended up on looks like a next inside of the block. And you also have some control for the the scenarios that you run. So there's a keyword argument as well that you can pass to test simulation that's very similar to what you can pass to perform all jobs before or after to sort of define a time range for jobs that you want to to run. So you have a couple of levers of control through additional keyword arguments to these helper methods.
Thanks.
Any more questions? I'd like a minute or two. All right. Thanks, Steven. Yeah.
Thank you.
We'll probably take like a 5-10 minute break for the bathroom and everything before Miles comes up wherever he went. Yeah. Where did Miles go? Okay. I was like, what?
Oh, there he is. To repair.
Oh. I was just like looking over there. I'm like, empty chair.
Oh yeah.
I'll move these for you. Yeah. All right. I'm actually gonna move.
Oh, okay.
Yeah. Sorry. Yeah. And actually have food.
Okay.
Yeah. The couch is yours.
All right. I don't think I need power, but I wonder if I should take the opportunity to hook it up just in case. So there's nothing else to do.
And 12.
Okay.
Yeah.
Whenever.
The full time.
All right.
Yeah.
Wow, yeah.
Yeah, I'll try to be fast. When I practiced it, it's like 45 minutes and I have to cut out stuff to do that. So, yeah. So we'll see.
Yeah.
That's the problem. It's kind of like a gazillion presentations in one.
I'm excited.
Yeah.
I think it's gonna be great.
Yeah, I've actually already done this before. So it's the first time. Yeah, so I'll be there. But that's okay. And you're welcome to sit there. That's funny. Well, this is 360 degrees. That might not be far enough. We'll see. No, I think you're good.
Yeah, so we are he's not people that's kind of but he's good enough. Yeah.
The rest of our development is something. We are. So actually, yeah. So even I actually go this is we got him. Yeah, I mean, oh, yeah. But he brought Steve in because they're we don't want to go back even. But for Sorrel, so yeah, we're not. They were going to build what they wanted to do yeah, capture and using AI. Never actually, never actually funny enough. Now we're actually good, yeah.
I think I have David picked.
Yeah, I should actually do it. I always forget how to clear the thing out. What is on the screen?
Hello. 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 Hi. The best way I can get people's attention. Hi. We're gonna get started with our second speaker. Miles came all the way from California to join us, so we're very excited today to speak. With that, I'm gonna give him the stage.
Okay. Assuming. Hey everybody, I was gonna introduce a software framework I made and just share some of my epiphanies, some things about my journey, some things about me and how I wound up at this point. Show some Ruby code, maybe do a code demo, time permitting. So yeah, let's dive in. So what is Foobara? It's a framework for building systems that are command-centric and discoverable. And why did I want a framework like this? I wanted a framework like this for dealing with projects with lots of domain complexity. So I want to give a timeline of my programming journey. So I started programming in 1995. Started programming professionally in 2001, discovered Ruby in 2007. Around 2008, I actually made a couple small bug fixes to Rails and a few small bug fixes to Engines before it was part of Rails. Engines was interesting because it offered a way to reuse Rails code, which was really hard to do back then. And there's a connection between code reuse and domain complexity management. But anyway, so I got my first Ruby job in 2012, which was awesome because I loved Ruby. It was my favorite language at the time. And then I worked on a project where I discovered a gem called the Cypress Mutations gem. It was a gem added to the project by a coworker. I don't know if, has anybody used that gem before? It implements it. What's that?
Use Cypress before.
Oh, this is not related to that test suite thingy.
Oh, okay.
Yeah, this is different. In fact, I might be misspelling Cypress there. I'm not sure. Or the test suite has a weird spelling. Does the test suite have a weird spelling?
I don't think so.
Yeah. Anyway, it's an implementation of a command pattern. And this project did not have a complicated business domain, but we were able to improve code reuse by encapsulating high-level domain operations in these commands. And on this project, we actually were able to separate the front end from the back end. The front end was Bower CoffeeScript, if folks remember that. And I forget the other details. Totally different like setup of JavaScript than today. But that was interesting. We were able to have a completely static front end, and the back end did nothing but handle domain logic for the front end. Now in 2014, I actually had my first encounter with a complicated domain, and this was a mortgage product, but we handled everything from top of the funnel all the way through to servicing and all kinds of other concerns like money movement, loan sales, appraisals, just an outrageously complicated domain. And I'll jump forward. That was also a Ruby project. In 2021, I actually encountered my second complicated domain, and this was just by sheer coincidence. This was a completely different team, completely different company, completely different tech stack. This was a Node backend with a JavaScript front end with React, whereas this over here was a Ruby backend with a mixture of Hamls and React for the front end. And this was really eye-opening. This project here was helping people who don't usually apply for benefits for electric vehicles discover those benefits and successfully apply for those benefits. And other than the domains being different, the same kind of challenges kept popping up. And I started to kind of notice those patterns in my coworkers as well, that the challenges were really just managing the domain complexity and not so much the technical challenges. So there's kind of this weird trade-off where once and I don't even know why this is, you get to a place where you kind of have a small number of gigantic transactions, and the difficulty isn't really managing those transactions. There's so few of them and they're so infrequent. It's really just doing them correctly. Or at least that's the pattern that I've ran into. Now, this third project was really similar to the second project. This was solar panels instead of electric vehicles, but a difference here is that I was the engineering manager on this project, and I had
complete freedom to do whatever I wanted with it from both the client and the employer. So completely drunk with power, I said, we're not using Node on the back end anymore, not to bash on Node or whatever, but we're using Ruby on the back end. I actually decided to move from JavaScript to TypeScript on the front end because one of the front end engineers was absolutely obsessed with TypeScript. And I was hoping that it would mean, and it did pan out this way, that we wouldn't have to test the JavaScript as much. It's difficult to test the JavaScript. They love TypeScript and felt they'd be testing it less frequently. I was like, let's go for it. The backend folks owned the domain and imposed the domain on the front end, and maybe I can kind of talk about that a little bit at some point here. Other things we did, I made the product manager. This could be its whole own presentation, so I should probably cut myself short here. An interesting thing I did is I made the project manager a sibling with me, and we basically pulled the engineers in two different directions, causing confusion and friction, which was a great thing because my message was, like, if you don't know what to build, I don't want you to build anything. And I kept saying that the thing that's going to kill us is not understanding the problem and not understanding the solution to the problem. So if you're getting mixed messages from me and the product manager, then don't write any code. Let's sit down and work this out. Anyway, this project was a really great success, and I was able to test out a lot of hypotheses I had. An important one was I decided to abandon REST for an RPC approach, even though we were using Rails. So we had one Rails controller action that could route to different commands. And this allowed us to, this was part of being able to impose the domain on the front end. By using RPC, we were no longer constrained in which verbs we could use. I'll get into that later. So I should actually move on from that. Long story short, this project it went really well, and it inspired me to go ahead and try to create a framework that I wish I had had on these projects. So I started a framework called Foobara. That was a couple of years ago, and then that leads us to right now, where here we are sharing this moment together in Chicago. Okay, so I'll get back to Foobara now. So again, Foobara is a framework for building systems that are command-centric and discoverable. I'm going to dive into what it means to be command-centric. Command-centric system uses commands as its public interface and the public interfaces of its subsystems. In Foobara, commands are the only primary concept. Then there's secondary and tertiary concepts, which I'll get into. This was intentional because I kept not making commands as important as I wanted them to be. And so I decided to treat them as the only primary concept. So what is a Foobara command? Foobara command is a code unit that encapsulates a high-level domain operation. So I was going to show some code that shows domain logic that is not encapsulated. Here in this slide here, we have a reservation controller for a capybara cafe, and this is a create action. So this is what we would call to make a reservation. So the front end would call this create action to make a reservation. And you can see here that you have in pink what is HTTP integration code, and in blue what I would consider domain logic. And you can see that they're blended together, which is actually fine if you have a small business domain. This isn't really going to cause much difficulty. You can refactor as you go if this starts to cause trouble. Similar with a medium amount of domain complexity, you're starting to play with fire there, but once you get to a large, complicated domain, I think it's a mistake to write code like this. And so I'm going to show a command example. Oh, so first I'm going to show a command example, but what would we call the command? At first, I might be inclined to just call it create reservation because it's going to be called from the create action in the controller. But I don't want to call it that. I want to call it make reservation because that's what the business calls this operation. They don't call it create reservation, which seems like a small thing, and it is until you're flooded with this stuff and everyone's confused. Okay, so here we have a command. This is a make reservation command. Has inputs. It has a result. These are typed, which is important. It has an execute method, which is an opportunity to write a self-documenting piece of code explaining the algorithm of the command, what's going to happen if you call this command. And all of this code is related to the business domain. None of this code has anything to do with HTTP. So how do we run this command? So coming back over to our reservation controller, we're calling it down here, make reservation.run, passing in a user and at. And now all of this code is integration code. All of this code is all about how do we make a reservation over HTTP. So some benefits of doing this. One benefit is that the domain concepts are clearly represented in the code, which I just mentioned. If you have a complicated business domain, I actually think this is the most important benefit. You're also going to get code reuse because you're separating concerns and improve maintainability, all the things that come with, separation of concerns. Talking again real quick about mental models. Here we have our reservations controller that could create, update, and destroy action, time slots controller with an index action. We already know that create is make reservation, but I wouldn't know what update is. And in my experience, the update could be any number of business operations or even multiple business operations bundled up in one. Destroy, I would probably guess, is cancel reservation, but even then I don't know, because it could be that to cancel a reservation, I set an is cancel flag and update, or transition a state machine via update. Maybe there's a different controller that exposes the reservation state machine as a resource. Maybe there's a cancel action, which violates REST, but happens all the time. And you guys have probably worked on teams where there's a tension where some engineers want to introduce a custom action because it uses a verb that they feel explains what they're trying to do. And then other members of the team understand this is a RESTful architecture. We need to introduce a new down for this. So can't have a cancel action. We need to have a cancellations controller, and we'll put a create action there, which again is fine. And that's the nature of that mental model and that approach to software. But just pointing out that there is kind of a tension there that I've seen on every team I've been on. And you have to kind of police it and pull requests and stuff like that. But anyway, what do these controller actions actually mean in this case? Well, we already knew make reservation. It turns out that update is what you would call if you want to reschedule a reservation. So make sure that your front end team knows that. Cancel reservation, that actually is destroy. Check availability turns out to be the index on the time slots controller. One thing about this one is something I've also seen happen, and this is pretty natural, and again, doesn't matter so much on projects with small or medium business domains. This index might actually return more than just what's available. And it could be that the front end actually has to implement a tiny bit of domain logic itself to get the actual availability. And that's not what we actually want here, at least not in this Foobara approach, where we want to impose the domain on the front end, not have them implementing bits and pieces of it. I'm going to show some separation of concerns reflected in the directory structure. This is real similar to what we just looked at, but here we have different types of integration code. We have HTTP, we have worker queues, job-related stuff, and then command line interface integration. Those are all located here. And then the domain logic, as we talked about, is smeared all over the place. So something you can do, and this isn't the only way to do this, and I'm assuming that a lot of you have had to wrangle this problem in some way, but a natural step for our team was, well, we're going to isolate domain operations into a commands directory here, and then we will call those commands from all these integration code units. So if it turns out that I need to find sooner time slots and offer them asynchronously, I don't need to cut and paste code or copy and paste code out of a time slots controller into a job that I'm writing. So this helped. This does give that separation of concerns. You can do this other ways. This isn't the only way to pull this off. I still don't quite like this. Looking on it, reflecting on this, commands are cohabitating with controllers. Commands are doubly nested, but the rake file is at the top level. So there's things I don't really like about this, but this is a huge improvement to maintaining domain complexity. Actually, for a lot of projects, this could be enough to like really help. So actually, I mentioned the Cypress mutations gem. If you just want a command pattern, but not the discoverability part, which we'll get into, I definitely can recommend that gem. Okay, so moving on here, I'm going to talk about discoverable now. What does it mean to be discoverable? So a discoverable system can give a machine-readable description of its primary operations and the related concepts that they depend on. So here we have our make reservation command again, and here we have some metadata. This is a screenshot from Firefox exposing this command over HTTP. We can see we have information about the inputs type. This is truncated. There's a lot of stuff here. The important thing being, we didn't have to write any of this manifest data. We just got it automatically by way of creating our make reservation command. So what's the implication of this? Well, looking at this again, we have the domain logic integration code combined once again. We already know a way to make good progress on this. One way to do that is taking this command-centric approach. So now we have a separation of concerns between our commands, our domain, high-level domain operations, and our integration code. Once we add discoverability, our system now actually looks like this. And the reason that it winds up looking like this is that if you do a good disciplined job of separating the concerns here, your controller actions and your jobs and your rake file tasks start to become really boring. You're usually just copy and pasting an existing one, changing the name of the command, maybe tweaking a little bit the way you're casting the inputs or something like that. But there's nothing really interesting happening in these code units. And so what you could actually do is just use that manifest data to just abstract all of that away. And that's a fundamental concept of Foobara. So the benefits I just mentioned, the integration can be abstracted away. Less code is generally a good thing. The domain logic is less likely to creep into the integration code. Actually, the domain logic can't creep into the integration code because there is no integration code. So that was another thing that our teams were always doing through pull requests, was trying to police that. Like, this doesn't belong in the, a real common one was you might wind up in a situation where you're trying to avoid queries in the views. I don't know if you've ever wound up down that path before, but that's really difficult to pull off in a big team of people who are doing things the Rails way. So anyway, domain logic is less likely to creep into the integration code because there is none. And so if you look over here, the domain model is a secret. It's a secret. Here, the system is actually communicating to you the domain model, and here the system is screaming it in your face. And that, I think, is, if you're trying to wrangle a big domain model, is the biggest of these benefits, which is actually the third bullet point too. The mental model is not only communicated but dominant in the code base. There's actually another benefit I've noticed, which is just that less code means faster development and testing. You don't really have to test integration or controller actions in this situation. You probably do want to do some kind of integration testing, make sure your sign-up flow works, or maybe something involving money. But you definitely, in my opinion, you shouldn't be doing something like make sure this controller action gives a 404 if the resource doesn't exist. That's something that you should just trust someone else who wrote the code that abstracted away the integration has already tested for you. Okay, so there's a few other concepts in Foobara. Command over here is the primary concept. A few secondary concepts. There are types. There's models, entities, custom types. There's domain mappers. Domain mappers know how to translate a concept from one domain into another. There's domains and then there's organizations. Domains are basically namespaces of all this stuff, and the organizations are namespaces of domains. One that's missing here that I really should add is errors. You also write errors. So there should be an error here. Over here, we have our tertiary concepts. We have color for these concepts because these are code units that your engineers would be writing to implement the domain. And it's also just the only code units they really should be writing, because the rest of this stuff would be abstracted away. These would be things you use from either Foobara itself or some third party that's already written this stuff. So there are command connectors. They know how to expose a command to the outside world. There, at the moment, there's a RAP connector, there's a Rails connector, there's an MCP connector, there's an agent, which is also a connector, and there's a rescue connector for async jobs and a rescue scheduler connector for scheduler jobs, and obviously can write whichever ones anybody happens to need. There's remote commands and really remote everything. These are very important because they have the exact same interface as the command. I think this is important for multiple reasons. One is, again, it allows you to impose the domain on those who are consuming it. But also it really helps with re-architecting and remodeling systems, because you can have a command that depends on 5 other commands and you might need to move 2 of them out to a different service. You don't have to refactor that command, because instead of calling the command directly, it's now going to be calling a remote command, which has an identical interface to the command. So I do have like some screenshots of some code examples. This is a type being declared here, which is an email address type, which is a string. It's down case. It has a regular expression. I don't know if you've worked on a project where the team is handling their own email code and forgot to make it case insensitive. And all of a sudden now you have a user with 2 accounts, with one's uppercase, one's lowercase. Now you've discovered a new domain operation, which is I need to merge two accounts into one account. Anyway, we're using that type here directly. We're also creating another type here, which is this judge here is also a Foobara type by way of being a Foobara model. We could actually declare this judge from this declaration data instead if we wanted to, but it's a much cleaner, natural sugar to just create a Ruby class. Here I have a couple more types. These ones are actually registered with names. So here's a decision and a denied reason. And I can use these types by using their symbols. So here we have denied reasons, which is an array of denied reasons. Here we have more custom types. Oh, this one here, I'm using an active record type, which allows me to use an active record model as a Foobara type. And one aspect of Foobara that I don't know if we'll get into or not, in Foobara, you can use primary keys or entity values in place of each other if you want to. So one thing you can do here is I can actually use the number 5 in place of an actual, I don't have to go fetch the capybara like with ID 5 from the database to run this command. If I have it, great, I can pass it in, but if I don't need to. Another thing to point out here, you'll see that I'm not actually loading the capybara I passed in. So even though this 5 is coming in, Foobara is actually going to load it for me. And that's actually important for things like authorization. Yeah, that could be its own conversation. Here I have some domain mappers. This domain mapper is kind of complicated to look at. Here's a little bit of a simpler one. This is a domain called AnswerBot, which has a real simple domain, very simple mental model. An answer goes in and a question comes out. They're both strings, but it's implemented using various different AI services like Anthropic, Olama, OpenAI. And so I need to be able to map into how to actually get an answer from those services. And then I need to map the data back. This is how it maps into the service, and this is how it maps back out. You can just see that the return values here are structured completely differently. By having these domain mappers, it allows an engineer to work on a command in the AnswerBot domain using only the answer or question comes in, answer goes out mental. They don't need to know about things like content or chat completion. These things don't exist because they're in the domain mappers. That's just another thing that can help with managing domain complexity. Here I have a command connector example. This is a rack connector, so I'm just exposing determined language over rack. Here's an example of a remote command. I'm importing determined language from that same rack command connector that I showed elsewhere. This is just a command that is going to tell me what programming language this looks like. Here we have a much more complicated example. This one is using the Rails command connector. I'm using some authenticators. I'm actually transforming some inputs here. So you can, if you need to, you can confine what you're actually exposing to the outside world. And here I'm actually moving a refresh token. I'm moving the refresh token to a cookie. I'm moving the access token to a header. So something to point out here is all Foobara command connectors support off like the same exact auth system as each other. So if I wanted to do this kind of authorization on the command line, I can. But if I'm doing it in HTTP, I'm using these various helpers to expose it in a way that the front end is expecting. And then here's actually the corresponding import command version of that. So I'm importing the AB compute exponent command, and I'm using an API key here. Oh, something I also forgot besides errors. In the tertiary concepts, there's also code generators. There's a whole ton of code generators, can write whichever other ones you like to write. There's a bunch of TypeScript ones because I use this with TypeScript a lot. So you can create remote commands in TypeScript. So you can have a back similar to the last project I worked on. You can have a backend that's just exposing domain logic written in Ruby exposed in a RPC fashion, and then TypeScript front end that's consuming those commands, and those remote commands in TypeScript have the exact same interface to whatever extent is possible as the commands on the Ruby backend. I could blast through this. I kind of want to like save time for the code demo. Here's kind of just showing, going back to our Capybara Cafe, here's kind of like a system of different components. The ones in colors are the ones you would actually write. The other ones you would use from some library. preferably, unless you happen to find yourself writing that library. Here we have a Capybara Cafe domain on the left here. It's using a generic reservation domain over here. This reservation domain doesn't know anything about capybaras, and it doesn't know anything about cafes, but it is an implementation detail of our Cafe domain. I have, just for demonstration purposes, another random domain down here. I usually like to think of this as just a Salesforce domain. So let's just pretend that this is a command that syncs reservation data to a Salesforce lead. A powerful thing I've discovered is that I should not be translating from this remote reservation to the Salesforce lead. I should instead be translating from the remote reservation to the inputs of this command. So that, again, just makes it more command-centric, helps us honor the public interfaces of these domains. So that was something I discovered along the way. Yeah, so again, I mentioned the ones in colored are, I think I can go through here pretty quickly. So yeah, here I had already mentioned we've got the reservation mapper mapping between these. Here's our command connectors. Probably these would both be HTTP command connectors. They don't have to be, but that would be a typical way to build an application like this. Here we have a remote make reservation, which I mentioned has the exact same interface as make reservation that it's proxying to on the right through the command connector. Like I said, if we wanted to, we could move this make reservations project into this Cappy Cafe mono repo on the left, and we could move this Salesforce domain at the bottom out into its own service without having to refactor anything in here. You probably would still want to test that it's going to work and stuff, but you're not refactoring. You're not, it's not HTTP anymore. I need to refactor these controller actions. We have a CRUD driver. It knows how to read and write entities to a data store. Right now, it can read and write to memory, to a file system, to Redis, and to PostgreSQL. PostgreSQL CRUD driver needs some work, but it does work. Oh yeah, and then last but not least, we have the end user over here. They're successfully making a reservation to meet a capybara for the first time. And that's only possible because the people who built the system understood the problem they were trying to solve and the proposed solution to that problem. I've actually never met a capybara, and it's on my bucket list. Doesn't seem like that hard of a bucket list item to cross off, but yeah. Something I wanted to mention, why did I choose Ruby for Foobara? There's a number of reasons, and a lot of times in these Ruby meetups, I guess we don't really need to talk about this stuff because it gets kind of to be sort of preaching to the choir. I think most people here are Ruby enthusiasts of some, at least to some extent. One reason is, to me, Ruby is real easy to test and therefore really easy to refactor. Something I didn't mention, on that third project when we started it, I told everyone we are going to model this wrong. No matter how hard we try to get this right out the gate, and we're going to try hard, we will get this wrong. And so we need to be able to remodel the system. We need to be able to re-architect the system, and we need to understand that from the start. It's easy to write self-documenting code in Ruby. In the electric vehicle benefits project I built, which was called Access Clean California, or I didn't build it. I actually joined once it was already built and then maintained it. But in that project, we did introduce commands in JavaScript, and there just was no real clean way to write a self-documenting execute method for those commands. And it's just the nature of the programming language. It's even harder in TypeScript if you make everything real strict. It's easy to write DSLs. I knew I was going to model this after the Cypress Mutations gem, which used DSLs for the command inputs and so on and so forth. Ruby's famous for being easy to write DSLs in. It's easy to create new code at runtime. I knew I wanted to be able to take a types declaration from one system and rehydrate it in another system and have those code units running at runtime as if I had written them from the beginning. And Ruby makes that easy as well through its meta programming. And then that meta programming actually plays a role in why the previous bullet items are there, at least to some extent. Ruby gems. I think we sometimes take for granted Ruby gems. I do have to say, not trying to dunk on like NPM and stuff like that, but going from a Node backend back to a Ruby backend, I definitely I appreciated Ruby gems in a way I hadn't appreciated it in the past. And I actually started working with this stuff before Ruby gems even existed, and it was a nightmare. So I should have known better. But Ruby gems is actually pretty great. So it's not something we should take for granted. It's fast. I rarely need to do weird stuff to deal with a dependency issue. And if I do, I kind of understand why I'm doing it. Friendly community. So Ruby has a friendly community. And also Ruby is fun. There's another reason, by the way, I knew I was gonna want, you can build things other than web backends with this, but I knew that was one reason I wanted a framework like this. And specifically comparing it to Node, Node runs off an event loop. Working with Node, I realized I feel like a threaded environment makes more sense for handling a request response lifecycle, especially if you're concerned with things like self-documenting code. The reason just being you can actually, if you need to, bundle up a whole request response lifecycle in a context if you would like to do that. Whereas if you're going through an event loop, there's technically a way to do it, but it's not real clean to do it. Whereas an event loop makes a lot of sense for a UI interface, but for a web framework, I don't personally enjoy using an event loop. I wind up with async await basically everywhere I possibly, like 99% of the places where I could use async await, I wound up using async await. When I was working on the back end. On the front end, it wasn't quite like that, but on the back end, it was like, if you can use async await, you should use async await. Yeah, so spending a lot of time on that. I actually don't have a time check. Okay. So I was gonna dive into some code demos, or I'll probably just do one code demo. Something I've been toying around with lately are these things called agent back commands, or I've been calling them agent back commands. It's been kind of a fun experiment. It results in some interesting Ruby code and some thoughts on things that I hadn't thought about before. So I was going to go ahead and demo that. Let me think of where I want to start here. So I have a loan origination domain. Let me see if I can find that. Let me go here. So here we have, well, actually, I know where I want to go. Sorry. Okay, so I want to start off here. So I'm going to do bin loan origination. Okay, so in this file here, I have like a demo loan origination domain. I'm connecting it with a command connector. And I'm kind of cheating here because I'm already including my agent back command and a couple AI services that I know I want to use. The reason I'm doing this is I want to create an AI agent that's going to underwrite loans with just one line of Ruby code. It's kind of a stupid thing to do, but kind of fun. So I'm going to do that. Yeah, so if I find loan origination here. Okay, so all I need to do here is I can do class. That is not what I want. Let's do review all loan files. And it's going to be an agent back command instead of a command. That means an agent back command, to explain what it is it's going to use Foobara agent, which is a command connector that I had mentioned earlier. It's just written in plain old Foobara and the Ruby standard library, but it's going to use it to implement its execute method. And so I should be able to just run this. And I skipped a step that I was going to show. When I run this here, load origination, I will see a bunch of commands that are connected here. It's actually really slow, probably because, okay. So anyway, here we have our review all loan file command that we just added.
Real quick, I think the TV's
on. Oh. Whoa, okay. So there's some lag there. So if I go here, I can actually get help from this. And I could do this with a command, with like an HTTP connector, like agent options verbose, because it's going to let me see what the agent is actually deciding to do. You can see all these different commands. This works with the Llama as well, but right now I'm only letting it use Anthropic and OpenAI. And yeah, so I am going to, I skipped yet another step. I actually need to prepare. So if I go up here, you'll see there's this generate loan files report command. I'm going to show you that command first because we need some loan files to review. Where am I? Sorry. That script is here. So this is using another command CLI connector, but it's in single command mode. So it's assuming I've already chosen generate loan files report. And it's really just going to give me a command or a report I can use to not have to look at the entire loan file tree. I'm just going to see the data that's relevant to the demo. So I'm going to run that, but I'm going to run it in a watch so that it will, this should update every 2 seconds, I think. Yeah, so coming back over here, I can actually now finally run this command. So I don't know if I still have this in my copy paste buffer. I don't. So I'm going to grab that agent options verbose. I guess I could have typed it. Okay, I'm going to give it a name because why not? Agent. Yeah, so I'm going to go ahead and run this, and it should start making decisions. While I'm doing that, I do want to show how this gets set up. So I also have a script, which I didn't show. I should have prepare demo records. This script here is what I ran to set up the demo records. Hold on. This is what I ran to set up the demo records. I'll jump over here. I don't feel like we have time to like really go into depth of this demo loan origination domain. But here we have a prepare demo records command. It's going to return a list. It's going to result in a list of loan files. It depends on these 5 commands. And then here we have that execute method, which just gives us that self-documenting code of what's going to happen if I run this command. I'm going to create 3 different credit policies, and they have different requirements. The idea being I want one loan file to be denied on credit score, one loan file to be denied on insufficient pay stubs, then I want one loan file to be approved. And I'm creating 3 loan files all the same way. So Barbara's going to get the one that's harder to pass on FICO score. Basil's going to get one that's harder to pass on income verification, and Fumiko's going to get the lenient one. To just show how that works real quick, this credit policy here is going to use the median FICO score. The other 2 are going to use the maximum FICO score. Your maximum FICO score is probably better than your median FICO score unless they're all the same. So that just makes this one harder to pass on FICO score. This one requires 2 pay stubs, and the other require 1, and that's why it's expected to give the results it gives. So, oh no, invalid. Oh, you know what? I forgot to delete this help thing. Oh man, so I did that. I went over to explain the domain while this was running to save time, and that's not going to happen. But now we can watch this together. We can see it making decisions. So we can see it choosing which commands to run here. It's running find all loan files. That's actually not the best command to run in this case, but it will work. Oh, here it's actually describing other commands. So I'll scroll down here, but we should see the data live updating over here. Oh no, we see everyone in review. It usually doesn't do that. So this might not actually work. Usually it does them one at a time. But here it seems, I've never seen it do this before. I have the temperatures all set to 0. If you thought that makes it deterministic, it doesn't. It just makes it like less non-deterministic. But here it's doing something I've never seen it do before, where it put all 3 in review before it then reviewed them. It usually does them one at a time. So yeah, that is pretty fun and interesting. We can see here that it's denying this loan file. Oh, another big deal is which credit score was used. This is an important factor in this domain. Loan origination, when you make a credit decision using a credit score, you want to record what credit score you used. And we see that we did get 650, which was the median, and 750 were the maximum, even though we didn't show that, but we could show that down here. So here everyone's getting the same credit scores with 650 in the median and 750. I'll show you another piece of code that is interesting that I've pre-written. Loan files. No, that's not good. It's this one. In here, this is the same file, and I wanted to code this together, but I think it just saves a lot of time to just have this pre-written. And then I will make some changes to this code to show some interesting stuff. Actually, while that is before we talk about this, let me try to make this happen again. So I'm going to prepare the demo records again. So this should set everybody back to in review. And then I'm going to actually run this script, review all loan files. So I'm going to let this run, and hopefully this succeeds while this is running, just so that we can have the output. But while that's running, I do want to talk about what's going on here. Here I have two agent-backed commands. So I've split it into two different commands. So review all loan files is still an agent-backed command, but now it depends on two commands: find a loan file that needs review and review loan file. And review loan file is also an agent-backed command now. It takes a loan file to review. It's going to return an underwriter decision, and it depends on these four commands. An interesting thing is if I wanted to, I can set this option, pass aggregates to LLM. And if I do that, the LLM is going to receive the entire loan file tree with all the associations pre-populated instead of receiving it with primary keys in the slots of things that are not yet loaded. If I were to do that, then the thing would no longer need this find credit policy because the credit policy is actually in the loan file tree. Anyway, so that's kind of an interesting thing. I've also decided to use GPT-4o here. And this here is defaulting to, I guess I didn't show that in the output, but this defaults to Claude 3.7 Sonnet. Yeah, so let's go look at the output here. We can see that it did the right thing again. We see 650, 750, 750, drafting docs approved, insufficient pay stubs, low credit score. And then if we look here, check this out. I have actually had it print out. I've actually made use of the agent-backed commands result type programmatically. So review all loan files has this result type, which is an array of these attributes, which is applicant name and decision, which is an underwriter decision. Down here, and this is the interface, this is still a helper method because I'm not creating an instance of the command, but I'm getting the outcome. I'm checking if it's successful. This here I only learned about last week. This is a write word assignment. Been around since Ruby 3, even earlier than that. I'd never heard of it before. I wound up running into a weird bug. Well, it wasn't even a bug. A weird thing happened when I used the in keyword. And someone said that's because it's the same as write word assignment. And I was like, what the heck is that? So this weird little snippet of code within that does something that seemed completely bonkers to me actually makes sense because, well, I don't know if it makes sense. But anyway, what I really wanted to do was use it in the block parameters here, but I couldn't do that. So interesting to talk about in a Ruby meetup, Ruby code stuff. I've only known about this for a week. Anyway, here I'm actually calling the denied method on decision because it's a proper underwriting decision model. And here I'm taking all the denied reasons and I'm joining them with a comma, even though we already know that this is not, I didn't create any loans that would be denied for multiple reasons. But this output here that you saw on this screen, this is me making programmatic use of the return value of an agent-backed command, a command where I didn't write the execute method. I just specified what the results should look like, and I got the data in that format. So I thought that's pretty interesting stuff. Oh yeah, let's look at the log here. You should see, let's see here. So one thing I do want to point out to keep in mind for later, if we can find a place, here we have the outer model, which is using GPT-4, or the outer command, review all loan files, which is using OpenAI. It's calling the review loan file command, not knowing that that command is itself an agent-backed command. And something just to point out here, because we're going to change this code in a moment, it's passing in the loan file by primary key, which it's allowed to do. And yeah, and then down here we can see review file, loan file is actually using Claude Sonnet. So here we have OpenAI and Anthropic coordinating with one another without knowing that that's what they're doing. So I don't know, I find stuff like that kind of fun. But anyway, what I was gonna say here, or what I would like to do here is, and this I find kind of interesting. I'm nervous about the fact that we have an agent-backed command here making a credit decision. So we have an LLM in effect making a credit decision, which is already problematic. And this is a demo. You probably shouldn't do that anyway. But anyway, it is a demo domain. This agent-backed command is receiving the loan file what's to say that the LLM isn't biased on the applicant's name, for example? So it makes me nervous about this because if I were putting this information on an ops console in front of a human underwriter, I would not put the applicant name on the screen because they don't need the applicant name to make a credit decision. It's irrelevant, but it could potentially bias the underwriter. So what we could do here is I'm going to introduce a new model, and I'll just put what I happen to already know is the only things it needs to make its credit decision, and I'll call it underwriter summary, and we want it to be a model. I'll say attribute. So it is going to need a loan file ID, but I'm going to explicitly give it the an integer instead of a loan file. It needs the, I know it needs the ID in order to approve or deny the loan because that happens to be interfaced to those commands. It still wants to put the loan file there, but that's not right. We do need the credit policy. So credit policy, and that's required as well. What else do we need? We need the pay stub account. And that's an integer and it's required. And then we want the FICO scores. And I can actually create a tuple of 3 integers if I want in Foobara. So integer, I don't want 4 of them. Okay. So here I have a FICO score of, or a tuple of 3 integers. And am I missing something? I am. I am going to now replace this inputs with the underwriter summary. So now I'm going to go back over here. I forgot to reset my, I forgot to reset my domain records, but now I've reset them. I'm going to run review all loan files again here. And now the outer command should be able to honor that new inputs interface that we just specified. And so let me see if I can find that here. So if we look here, you'll see review loan file being called here, and we see that triple of FICO scores, the pay stub count of 1, and the loan file ID, and then the credit policy. It could pass the credit policy, like other things for the credit policy, but it's choosing to pass the ID. Actually, I think the way I coded this up, it can only pass the ID. But anyway, coming over here, we can see that it's doing the underwriting the same as before. We see insufficient pay stubs for Basil. He's denied. Fumiko should go into a review and then be approved, which is taking a while. And there might be a problem. Jump back over here. No, it's just being really slow. Okay, so now Fumiko has been approved and she's in drafting docs. We used her right credit score. So I found this really interesting and it's something I wanted to share with you guys. This actually has nothing really to do with Foobara, but just kind of an interesting snippet of Ruby code, an interesting like epiphany, or it's not really an epiphany. It got me thinking maybe there's a future where when we're starting out a new project, and while the business is small, there's very few customers, we don't really understand the domain very well. Maybe we have a situation where we have a bunch of agent-backed commands or something similar to it in whatever like coding you're doing. Something that's using LLMs to operate a domain, to fill in the gaps of the domain that we haven't actually written the domain logic for yet. And then maybe as the business scales and that starts becoming cost prohibitive, because running this with Cloud 3.7 Sonnet is actually not that expensive. But if you run this repeatedly with Opus, it starts to like really add up. But with 3.7 Sonnet, it's actually really cheap. And you can also do this with Olama. It doesn't work with every Olama model, but shockingly to me, it works with some Olama models. It's much slower, but it works. Sorry, so let me get back on track. The thing that is interesting to me is we might live in a future where sometimes we use an LLM to fill in a gap in our domain logic that we haven't written yet, where it's operating the pieces of the domain that we have written to accomplish its own task, its own command or whatever equivalent. And then as the business scales and we start to understand the domain itself better, we actually then go in and handwrite or write real domain logic and replace the LLM. So instead of like, let's go through our domain and look at what we could automate with an LLM, it could be backwards, where it's like, let's look at what we automated with an LLM now that our business is scaled, it's outrageously expensive, it's slow, it's inaccurate, and now we actually understand the domain model better. Let's go in, and now is the time to like replace that LLM being delegated to with the actual domain logic that we expect. I'm not predicting that that's actually what's going to happen. Probably not going to happen, but just an interesting thought that I had. And it's backwards from where my intuition was, where find code, replace it with automation. This is find automation, replace it with code. Had another thought along those lines, but I guess I lost it. Yeah. So anyway, I do know what that thought was. Here's another interesting thought. The reason, so we broke the contract between these two commands. If these commands were not agent-backed commands, that would have been a problem because, and this particular piece isn't surprising, review loan file, and I guess I should be looking at these. Review loan file here, when we change the inputs from loan file to underwriter summary, it makes sense that we would have to change the domain logic inside of review loan file that used to dig that data, the data it needed out of the loan file, now needs to dig it out of the underwriter summary. That makes sense because we broke this contract here, so we need to fix the code here. But we also broke the calling code, which in this case is review all loan files. So we would also need to come here to review all loan files and find its domain logic where it was passing in the loan file, and we need to change that to now construct and package up an underwriter summary to pass into review all loan files. And so it could actually be scary to break this interface because you could break calling code, which could even be happening remotely. What's interesting here, though, is that these contracts are being leveraged at runtime by the LLMs. Like there's no actual domain logic. So it's just like something that kind of shocks me here is it dawns on me that the domain logic implementation itself, in this case, is what's coupling these two code units. And I never would have thought of it that way. I would have been like, this is the contract, you don't break the contract. Wouldn't have thought you don't break the contract because if you do, the domain logic will break. And to me, that was just an interesting thought. So I figured that'd be interesting to share, that the coupling comes from the domain logic. Not saying avoid writing domain logic, you should write domain logic, but yeah, so that was kind of a bit of an epiphany for me. I think I'll just leave it at this code demo. I think I had other code demos. I did want to, I know what else I want to do. I guess I should do a time check. Am I okay? 5 more minutes? Okay, I'll blast through this. I did want to show how the code works. So here's the agent back command, and it has this execute method, so we can see its algorithm. It's going to build an agent if it needs to. It's going to run the agent, handle its outcome. The agent is a command connector, like I mentioned. It gets its job done with an accomplish goal command. Accomplish goal has this execute method, and I highlighted these 3 lines because this is the heart of the algorithm. Until the mission is accomplished, or we've given up, or we've been killed, determine the next command name and inputs, and run that command name and inputs. So it's just kind of interesting to me how conceptually simple the algorithm actually is. I actually have more code here that goes deeper down the stack. I feel like something I should mention real quick. I'm just going to talk about MCP. Let's see. Oh, yeah, let's jump over here because this is important. So what am I doing here? That might have been a good place to start, but I thought it'd be fun to share some interesting things that I've ran into along my journey, not just recently with this Foobara stuff, but going back, over a decade since I first encountered domain logic and then encountered 3 projects in a row with high domain complexity. I'm eager to find folks who might be interested to build something with Foobara. At the moment, I'm kind of like a Rails without a base camp, and that's sort of dangerous because I can make design decisions that theoretically seem to make sense, but practically are terrible design decisions, and you often don't know that until you're actually trying to do something with it. I'm eager to find folks who might enjoy contributing either art or code, documentation, helping out with whatever. What else? And then also, if anyone's new to programming or Ruby, I also like pairing with people. I actually have a hard time finding people to pair with these days, but if you're learning Ruby, even if you're not learning Ruby, if you want to pair on stuff, we can pair on your project. I know that, was it Steven or Michael, the gentleman who did the first, was it Steven? I know how to use, I could help him out with RSpec if he wanted. I'm happy to pair with people on other projects. I know Michelle mentioned that there's a Slack channel, so I'll try to get in there. And I guess I can meet people there. And also, I wanted to say thank you. This is the first time I've actually demoed Foobara to a group of people before. So I'm really thankful for the opportunity. So I want to thank ChicagoRuby and Michelle, Anton, Dan as well. And yeah, so thank you very much. Really appreciate it. I don't know if anyone has ever come up with this idea before, and hopefully this isn't like blasphemous to either the Chicago flag or the Ruby logo, but yeah, you're welcome to steal it if you want it. Oh, and then I have a couple of QR codes. Don't really need to because each of them lead to the other one, but one of them is the main mono repo on GitHub. It's actually a pretty big project, but that's the main mono repo. And then on the right is kind of just a contact page that has, my email, Discord, whatever. So yeah, this would be one way to get in touch if you don't find me on Slack. Is that it? Yeah, this is actually my last slide. So yeah, thank you very much. I really appreciate it.
Nope, very late, so we'll give you like 10 minutes of questions. Yeah, go for it.
All right, so first of all, this should be like 3 hours long. There are like so many really interesting ideas. I wrote one of my notes I wrote down is such glory PSL. So let's talk about the PSL thing. So like this to me is like your version of like Rails. Like DHH has like Rails, right? You got adoption because it looks like REST. You have this. This is the way your mind works. What do you think? I'm not saying one of you is right or wrong. They're both like glorifications of like the DSL beauty that you can have with Ruby, which like so many people hate, and it's very confusing to me. Let's just focus on like the big other elephant, right? Rails kind of thing. What would you say to users that like this is worth using?
Ooh, that'd be a hard sell. I guess I would say, and probably a lot of you have already encountered this problem, but do you guys remember the fat controller, fat model problem where
it's on your slide? You have a slide about it.
Did I? Oh my gosh.
It's your slide where like all the blue and the pink is all mixed together.
Oh yeah, that was a fat controller. So we responded to that in the community about over a decade ago by pushing all that domain logic down into the model, which made it reusable because now you can use the model in the controller action, you can use the model in the rescue job. So it solved one problem, but then the models became unwieldy. They're wieldy if you're, and again, I think that it's an interesting thing because Foobara has nothing to do with AI. And so a whole conversation to be had about MCP and stuff where MCP, maybe that would be a potentially convincing thing, I guess. And I don't know what DHH would think about this. I feel like MCP, and I don't know if you're familiar with how MCP works or whatever it is. I feel like MCP is trying to expose a discoverable interface to your domain so that the MCP client can operate.
And it is command-centric like you want. Like
yeah, they call commands tools, but it's a similar idea. There's also resources which I intentionally don't expose. That's a whole other conversation. You can't, I will say if you want to expose resources, I think you should plan for that from the beginning of your project. You don't want to get 4 years in and then be like, surprise, our database is the public interface to the system. So if you're going to do that, great to know. The sooner you know, the better. Anyway, let me get back to that. So that would be one. MCP popped up long after I built Foobara, long in tech terms, I guess. And it was really easy for me to use existing commands with an MCP client. I wrote the command connector once, and then boom, all my commands could be called by Claude Code, for example. So I have like videos on YouTube where I tell Claude Code to do stuff, and it's calling Foobara commands and pulling it off. Anyway, I guess that might be one. He might not be so interested in that. I do think if you have a complicated business domain, you need some. It doesn't have to be Foobara. You need something between the controllers and the models. Like the fat models won't be good enough, and you can try to use engines and microservices and everything to figure it out, but I really feel like you're playing with fire because you're hardening interfaces long before you even know what the interfaces should be. So I do think the Rails way all by itself isn't sufficient. DHH might say, well, go ahead and just add that layer. It's easy to do to an existing. So I don't know. And Foobara is compatible with Rails. I mentioned there's a Rails command connector. So probably one of the safest ways to use Foobara, since it's such a young project, would be through like let it live parasitically off of Rails, because you don't have to worry about emailers, or you could use Active Record if you wanted to. So, but it can actually stand alone as its own project as well. Long story short, I don't know how I would, and I love Rails, by the way. I don't know how I would convince someone. I would have said don't use Foobara use Rails if you are in that large domain complexity bucket. But my experience with MCP and just like the time to delivery using Foobara and stuff actually makes me think I would probably want to use Foobara for any level of domain complexity, unless I thought I was going to start having performance issues.
I think your argument is exactly what you started with and what you like kind of have as at the end as well, which is the command centric operation and like the story that like the complexity of the internet and software applications now being passed with the simplicity of REST.
Yes.
And like you discovered that through a bunch of different projects at the beginning of your timeline with like, I want RPC, I want commands,
yeah,
like one interface because I can do whatever the hell I want for them. I don't need some other verbs or whatever structure.
Right. Yeah.
And like that is coming to fruition now. This is like a nice presentation. This is coming to fruition now with MCPs
right.
and other like the flexibility that we have with modern intelligence.
Yeah. Something to point out, the agent stuff we went through, the agent back command, it does not use MCP. It just gives Foobara metadata to the LLM and says what command, here's the progress I've made, here's the Foobara metadata, what command do I run next? Which is kind of similar to what MCP is doing, but it's actually not using MCP.
It's like unstructured.
Yeah, yeah.
I have more questions from us.
Yeah, yeah.
Right, cool. So another thing that was like a really, really cool idea is the pass by reference versus like I don't care about whether you pass by ID or pass by reference.
Yeah.
Yeah, I haven't seen that before, but that is like often re-implemented in lots of other frameworks and stuff.
Oh, is it okay?
I don't know, like
yeah.
in building Rails applications, right? Like, or any other like application stuff, you tend to have to do one or the other of those things in many other interfaces. So like building a single abstraction for it is like very nice.
Right.
That was cool. Oh, you mentioned another thing at the beginning. So you mentioned that there are models and there are entities.
Yeah, sorry about that. So models would be more like a value type, and entities are like an active record. It's an entity type. So it's an entity is persisted and a model is not. So you could have any kind of nesting of models and entities you want, but the entities are written to databases, and the models are kind of, you could almost think of models as like attributes with a name to some extent. They're not actually attributes, but yeah, that is a good thing to point out. I should have pointed that out. Yeah, and it might not be the greatest naming. It might be confusing.
Well, so one other thing that your stuff reminded me of is, this is a whole other religion, is domain-driven design.
Yeah.
Because they have the idea of an entity and a value, which I think maps to your
model
in an entity.
Yes, so that maps really well. When I mentioned the thing with the aggregates, where if I set that aggregates flag, I wouldn't need the find credit policy. That terminology I took straight from domain-driven development. One other thing I took from domain-driven development is in that last project that I had success with is I forced the project manager and the client to do the domain modeling with me. And we just modeled the models, like the data type, the nouns. Domain-driven development advocates that you do event storming, which you're figuring out what's everything that like could have happened in the system. And that's one valuable way to do it too. Just like I feel like any way of doing that, I think is a good idea. So that was another thing I took from domain-driven development is like, I don't want engineering to come up with a mental model. They have no chance of coming up with the right mental model and then having to backtrain the business on that incorrect mental model, which on those first two projects happened in both of them. Engineering is completely delegated the task of figuring out the domain modeling. They come up with their own mental model. It's totally wrong. They have no clue. And then they have to train the business on that incorrect model. And that is not, that's a path to be on to spend years building the wrong thing without knowing about it. But yeah, one thing I will say about domain-driven design is it says not to use anemic models. I don't know if you're familiar with that concept. Foobara totally embraces anemic models. It's one aspect of domain-driven development I totally disagree with. So I actually think you should use anemic models. And I don't agree with the DDD argument. Overall, I kind of think of DDD as a toolbox. What's that?
You made one in your demo.
Yeah. I think one thing I would say is DDD, I think of it as a toolbox of patterns that you can apply, like pick and choose from. And I actually think if I build a real project with this with somebody, there's going to be situations where I need to have communication. The domain mappers aren't going to be enough. And when I wind up in a situation where the domain mapper won't solve the problem, I'll probably have to dig into that DDD tool chest to come up with a solution to keep these two domains separate and clean, but allow them to communicate at the appropriate times. So I partially subscribe to DDD, and I view it as like a toolbox to kind of pick and choose from. Yeah. But I do think it's a great thing to read up about if you have worked with a complicated business domain, because you're going to run into a lot of stuff where you're like, that's what we were struggling with. And it took us like a year or two to identify it. Like, it would have been nice to just have known to look out for this. I like another one, and I know I'm over, but we had one loan table with one interest rate column. But we had top of funnel, we had origination, we had servicing, and other domains, like at least like 7 or 8, but those were like the 3 biggest domains. Interest rate means something different in the top of the funnel than it does in origination, and it means something different in servicing than it does in the others, even though it has the same name. And same thing with loan. Loan doesn't mean the same thing in those 3 domains. It has the same name. So a takeaway from domain-driven development would be, it's worth seeing, do I actually have multiple domains here or not? And if I have multiple domains, it's totally fine. Have 2 loan classes, have 3 loan classes, have 7 loan classes, and that's could be what you need to do to manage the domain complexity. So that's another technique from domain-driven design that I really like, or that resonated with me. Yeah, I think I went over. Yeah, thank you. I really do appreciate the opportunity.
Have to wait until like 10, but feel free to leave. You need to.